Welcome back to the lesson. My name is Mr. Wong, and today we'll be looking at Chemistry Module 8, Applying Chemical Ideas, Inquiry Question 1, Analysis of Inorganic Substances. We're going to be focusing on gravimetric analysis. So we're going to look at some investigations of the method of gravimetric analysis, and we're going to process some data involving this process. If you want to do further reading of the topic, these are the textbook references, and here we go. So there's two types of gravimetric analysis. One is called precipitation, the other is volatilization. Let's talk about what they are. Our main focus here is going to be on precipitation though. So what is gravimetric analysis? It's an analytical technique that uses the mass of a substance to determine the desired ion that you're searching for. So for the process to work, the substance that requires analysis must be separated from the rest of your mixture. There's two ways you can do this separation. One is through precipitation. So by analyzing the ion by measuring the mass of the precipitate formed of that desired ion, or volatilization, measuring the mass before and after heating and removal of a volatile substance. The main one we're going to be looking at is, like I said, repeat again, precipitation. So when it comes to using gravimetric analysis, the most common example of this is fertilizers. Gravimetric analysis is commonly used for fertilizers dissolved in water, the solution is precipitated, and a solid precipitate is dried and weighed. So those are the processes that need to be taken into account when doing a gravimetric analysis. Dissolved in water, precipitated, dried and weighed precipitate. If we compare the initial mass and the precipitate's mass as a percentage of composition of an element or compound, we can then determine the exact weight or the exact percentage that was originally in the compound that we were looking at. Okay, so let's just recap on these steps. The first step is to ensure that it is dissolved in water. Okay, once you've done that, you add an additional compound or you add an additional ion in excess. So this is where you add additional excess set chemical. This is going to cause precipitation. Okay, once we get precipitation, we are going to remove all the other liquids, or we're going to filter it out. So filter the liquid, and we are going to dry the solid, and we're going to measure it afterwards. Now the reason why we do this step is because, remember, the precipitate we get at the end is the element or compound that we want to investigate. Okay, so you only use the chemical that will precipitate the thing that you want at the end, not the other way around. Okay, so these are the sort of steps, if you want to remember. And we'll use the fertilizer as an example. Weigh the mass of the fertilizer. That is important. That will be the initial mass. So that's the initial mass of the compound you're investigating. You're going to dissolve and filter out the mixture afterwards. So this is where you add water, and then you're going to filter out any residues that doesn't go through from the filter. Okay, once you've done that, you're going to add the chemical that's going to form a precipitate with your desired chemical. In this case, with fertilizer, we're looking at sulfate. Okay, so whatever combines well with whatever precipitates with sulfate, like barium, that will form our precipitate. Once we've done that, we're going to do another filtration, and we'll take out the filtrate. The filtrate is the liquid component we're going to be taking the solid component with us. That solid component will be rinsed with water or deionized water and then dried and weighed like that. This final step is just to ensure for purity of our chemical. So those are the major steps that you need to do. Okay. So the example we used just then was sulfate. And we know that ammonia sulfate fertilizers provide both nitrogen and sulfur, which are important nutrients for plant growth. By adding in excess amount of barium ions, we can form the precipitate of barium sulfate, as you can see, the solid. And that can help us to analyze the amount of sulfate ions that is in our fertilizers. Obviously, the higher the percentage, it'll be more ideal for our fertilizer to provide nutrients of our plants. Now, barium sulfate is very insoluble, which is why we want excess amount of barium to react with it. But there are some assumptions that we need to make when we do this process, and that is assuming that the barium ions only precipitate the desired ions, which is sulfate. In reality, depending on what chemicals or ions you have in the fertilizer, the barium might precipitate out some other ions that are not sulfate. So for the simplicity of our calculation, we do only just assume it's just the desired ion that is being precipitated. Okay, so these are the steps that we talked about. You need to weigh the mass of the fertilizer, dissolve the fertilizer in water, filter out the residue, so that is the solid, add excess amount of barium ions and form a precipitate, filter the solution and remove the filtrate, the liquid, rinse and dry the precipitate, weigh and dry the precipitate. Now I might just make one comment here. So here I wrote barium ions. If you're looking at more a general step, like as a general kind of quote of what to do, then you would just say ions that will precipitate the desired ion that we're looking for. Okay, so you can change it like that. All right, so the important part now is then how do we perform the calculations of our precipitate? There's a couple of things you need to make sure you do. Make sure you have the correct chemical equation, correct stoichiometry. Make sure that your precipitate is dried, so we have a constant mass and it's not changing, fluctuating because of evaporation of water. And you need to make sure you have excess amount of precipitating agent. In this case, if we're talking about fertilizers, the barium ions, just to ensure we precipitate all or as much as possible, if not all, the sulfate ions that we were initially investigating. Okay, so let's do a practice question. So we have 10 grams of fertilizer containing ammonium sulfate and barium chloride being added to it. The barium ions react with the sulfate ions to form a barium sulfate solid. Neither the chloride nor the ammonium ions form a precipitate, so that stays in solution. The solid barium sulfate is extracted by filtration, dried and weighed. The mass of the barium sulfate is precipitated, that's the value we'll have. Determine the percentage of sulfate in the fertilizer. Okay, so I'm going to go through explaining how we do this question here. If you don't want spoilers, you could just pause the video here, but we'll start. So first thing is just making sure we have the correct equation. So we're having the process of barium 2+, that's an ion, mixing with our sulfate ion, which is 2-. So we get the equation of BaSO4, and that is a solid. The next step we need to do is measure out the mass we have. Okay, so the next step is to determine the mass of our sulfate ions. Okay, and that can be done with the following equation. We want the molar mass of barium sulfate. Okay, we want the molar mass of our sulfate ions. And then we want to times that by the mass of the compound. Okay, just an acknowledgement of why we're doing this. If we have if we know the molar mass of barium sulfate, we also know the mass that will be contributed by the sulfate ions. So if we can work out this as a percentage component of the mass of the barium sulfate that we used, we should be able to work out approximately how much of the barium sulfate mass that we extracted was contributed by the sulfate ions. So let's just find the values of these. So the molar mass of barium sulfate is around 233.4. We know that the mass of the barium sulfate is 8.25. And we know the molar mass of sulfate is 91 or 96.1. So that gives us a mass of around 3.4. Just a quick round off here. You should use the complete values, so just keep that in mind. The next bit we want to work out is the percentage of sulfate in the fertilizer. So the percentage of sulfate in our fertilizer is going to be 3.4 grams over the 10 grams of fertilizer we used, times that by 100 to give us our percentage. And we find that 34% of our fertilizer is made up of sulfate ions. That's how you do the question there. Okay, so that's the completion of this question. I'm going to move to question 2 and let's have a look at how we do that one as well. Okay, we have a 5-gram sample of iron ore that's being treated to precipitate all the ion of iron 2 hydroxide. If I have 1.75 grams of iron oxide from the precipitate, calculate the percentage of mass by mass of iron in the core. Okay, so the first thing we need to know is how many moles of iron oxide do we actually have? Okay, so I want to know the number of moles of iron oxide. The mass is 1.75. The molar mass, I'll just search that up, is about 159.70. So that gives us a total or number of moles of 0.01906 moles. So that's what we have of the number of moles of iron oxide. The next thing is we need to work out the number of moles of iron, because the question is asking the percentage of iron by mass. Okay, if you actually look at the formula here, there are 2 iron atoms, or atoms for each iron 3 oxide element. So it'd be 2 times the number of moles of iron 2, 3. So 2 times 0.0 of this value, which gives us 0.02192 moles. Okay. Now that we found the number of moles of iron, we can now work out the mass of iron that was in the sample. Okay, so we know the formula is number of moles divided by mass times molar mass. So the mass of the iron that we used is equal to the number of moles of iron times the molar mass of iron. So the number of moles, 0.02192. The molar mass is 55.85 grams. That gives the number of moles we used, as 1.224 grams. Okay. Next is working the percentage of iron. So the percentage of iron, is the mass of our sample. So the mass of our sample divided by the mass of iron we used times 100%. So that'll be 1.224 divided by 5 times 100. Make sure that it's very clear that it's 5. So the approximate percentage we get is about 24.5%. And that's how you do the question for this one here. I guess one of the last things we can talk about is what are some potential errors that could come from galvanometric analysis. And the main point is contamination of other species. So not having clean vessels for the reaction. There could be potential loss of sample due to ineffective filtering, spillage, or rinsing of the containers. We might not always get the desired species in the precipitation solution, so as we said earlier in the lesson, they can potentially precipitate other chemicals that we don't need to analyze, and if the sample is not dried. So please make sure when you're doing this practically that you take into account these 4 factors when performing a galvanometric analysis. And that concludes our lesson for today. So hopefully you get a better understanding of how galvanometric analysis works. Next lesson we'll probably start looking at precipitation titrations, but that's another talk for another day. Thank you for joining. Give the video a like to support other videos coming out in the near future, and have a nice day. Hopefully you enjoyed the video.